Okay. Hey, hi everyone. This is Joan from Openfort. You'll have to excuse a bit my voice. I'm a bit cold, so I might just like take a couple of like sips of water in between the presentation. I'm here to introduce you OpenSigner. This is a project we've been working for the past 6 months, give or take. And it's implementation, like a key management implementation that we use also internally at Openfort. So yeah, OpenSigner is an open source self-hostable key management solution. And so when we sit with our team a year or so ago, the space was already like pretty developed with a lot of solutions in the market that were going through, okay, how do I make my users sign in through applications in a smooth way, embedded wallets, cross-app wallets, global wallets, like all this jargon across, hey, we actually want to abstract as much as possible the whole management of seed phrases, passwords, etc. One of the main problems that we saw with these solutions today is that for the most part, they all lock you down into a specific architecture. And so when we sit with the team, we're like, okay, what are the components that we see in today's wallet that are actually required for you to abstract as much as possible from the user while keeping as much sovereignty on the infrastructure to offer that service, right? And so here basically I outline some of the criteria that we decided to follow, one being yet as little vendor lock-in as possible. Obviously, being custodian is pretty straightforward, but like offering this at the minimum requirement of like being non-custodial is like extremely critical. And then one of the parts as well on like how we decided to design OpenSigner as well, is that we wanted to be as agnostic as possible to any sort of solution that existed today. That means that you could actually use OpenSigner in any chain, that you could actually use OpenSigner with any auth provider solution that you are familiar with, etc. And so this is kind of like the checkbox that we kind of like, been trying to develop towards and kind of like being very, pragmatic and strict to comply. So obviously MIT license, so anyone kind of like free to like work, self-host in any fashion that they want to, they don't have to ask or any license around it, etc. The other important part, obviously, like keeping as much as possible the non-custodial aspect of it. I think, one of the, like when you spend some time within like the wallet infrastructure space, you actually realize that it's kind of like hard to see what parts of this architecture of people, like of other solutions, are actually custodian and what parts are not. To give an example, for instance, there were some projects that on paper, when you look at how they manage the key, like the whole splitting, like different nodes, et cetera, makes sense. But then when you specifically look at like how do they authenticate these users first within their system, you actually realize that because they control the authentication provider, they can actually issue any sort of like JWT token that they wanted. So they could actually re-authenticate themselves within their system and actually extract any keys that they wanted. And this was like completely unrelated to the key management that the system had in itself. It was just on the authentication solution, right? So there's like a lot of nuances on like how you actually apply and like plug and play these different systems. And the last of it is kind of like being chain agnostic. So today we've tried with different curve, like signature curves. So you can have Ethereum one, Solana. We also build like a proof of concept on Bitcoin, etc. But that's kind of like the idea of like how we landed to OpenSigner. And so one of the, obviously, we're gonna get a bit deeper on like how technically looks like and how we kind of like recreate the private keys, etc. One of the key primitives that we built OpenSigner on top of is the Shamir secret sharing. So this is like a very kind of like old battle-tested algorithm to split private keys or like any other set of like secrets. We also build on good ideas within the space on like shoulders of like giants. For instance, on the self-hostable part of it, if any of you have been using Signal, it's like a very like the approach to the way that they encrypt their secrets is pretty straightforward. It works pretty well because they have an entropy that they ask to the user, and then they store that secret within their database. But without your entropy, they can basically do nothing. This is like a very simplified version of it, and you can do the same with wallets by asking the user to put like a PIN code or a password. But in either case, these are like different design spaces that later on can be applied to wallets as well. And yeah, we also audited this with QuantStamp for people to use. All right. So the way that OpenSigner works is that we have different components of it. One is like all obviously like you can self-host, and we're going to get into this. But like one, it's the iframe. This is basically where the private key is created and split. And then that split of the private key, which I think I had somewhere else, this this split of private key is then stored in like these three different components. One is the local storage. Then you had the hot storage and the cold storage. So what does it mean? Like basically, hot storage is the place that you would have your own like Postgres SQL database. It's like in itself, it's shared. It's like completely useless. Like you can't do anything with it. So this part, like the hot storage in itself, like you can build your own implement. We have a sample implementation on Go that you can use, but you can build it to like depending on your own authentication solution that you want to use. So if you're using Firebase, BetterAuth, et cetera, you can, or like just a simple email password, you would put like you would store it in that database. Then we have the cold storage, and this is basically where we put as much kind of like attention as possible, because the way that it works is that once you split this private key in three different shards, the cold storage becomes kind of like the weakest point, because if you want to self-host, the cold storage needs to be the place where you actually either encrypt one of these third recovery shares with the user's password, or you basically can encrypt like using other methods, like when we look at the passkeys, PRFs, and things like that. Now, the way that so we just talked about how we are creating these keys on the iframe, and then you split it and store it in different places. But the crux of it all is like how we actually recover these wallets, right? So a user first logs in into the platform. You create a passkey. You want to sign something. Then you use the hot storage and you use the local storage. 2 out of 3. And you create it and you sign the transaction, all good. What about recovering this this private key? Well, to recover this private key, then we will use just the hot storage and the cold storage. Now, the way that we recover the content of the hot storage is by an OpenSigner offers 3 different methods. The first method is the password, so it's basically the user saying, "Hey, my PIN code is 1, 2, 3, 4." Please don't do that, but you get the point. And so once you encrypt this, it is stored on the cold storage, and then obviously no one can see that and touch it. Then we have an automatic method. This is like a more more complex method. It adds more variables, but it's also an interesting one, and it's basically using the encryption that the developer, an encryption that the developer gives us from their own backend, and an encryption that comes from the cold storage in itself. Now, if you are self-hosting, the automatic is a bit tricky, because you could technically reproduce the private key, because you are self-hosting the hot storage and the cold storage, and you are seeing those secrets from the developer's backend, which is your own. What we do to mitigate this part is basically offering an OTP validation. And so with the OTP validation, basically the user needs to put like a one-time PIN on the recovery kind of user flow. And so in that case, we add an extra layer just to validate that, okay, this is the user actually asking to recover the key. It's not the developer doing it all in itself. And then the passkey is the one that I'm really, really excited. Probably many of you are familiar with Face ID or similar methods to unlock the device. But there's an extension of passkey that it's called PRF. And it's actually super cool because it allows you to actually encrypt data. And so you could actually, for devices that, which today is, I think, most all the Android and Apple devices, you could actually request the user for a passkey signature that encrypts on device, on local, the recovery share. And so you can just save that recovery share encrypted with passkey from the local from the cold storage directly. And this is actually like a super cool method because it beats the other two out of the park. One, because you don't need to actually remember as a user what's your password. Like, you don't remember if it's like 1234 or 888 or whatever. And also because it has no dependencies. So literally, even if automatic is better for the user from a user experience because you encrypt it directly with the shares that I was mentioning on the backend, you have zero dependencies with any other part of the system. And so it's the one that we're actually pushing like any developers to adopt and start using it. The only caveat with passkeys, which is still like a kind of like being pushed for the ecosystem to adopt, is that some secret managers are not working very well with PRF. So if you use LastPass or similar secret managers, like sometimes it prompts like errors that they cannot work with this sort of like encryption. And so it works though very good natively with Google Password and Apple Password. So it's getting there. Then this is just like a very self-explanatory architecture diagram. What I was trying to explain here is like if you go from a mobile app or a web app, basically the flow of key management here would be that the user logs in. From the login, you go into logs in into an auth service that you can choose. Then the auth service basically validates that the user UID is correct on your database, and it passes well with the JW2 token. Once the afferent validates this, it creates the private key, and it splits it in like these 3 shards that I mentioned before. And so the first 3 shards goes to the auth service, the hot storage, and the cold storage. And so basically the idea here is that you always would need like a 2 out of 3 in any sort of like in any sort of like shape or form. And so for the first time that you are creating the private key, the way that you would be signing is usually using these 2. And the reason you're using these 2 is very straightforward, is because it's way faster to do a 2 out of 3 of a method that you have on device and the one that you are authentication, that basically reaching out where like in whatever region or geography that you have your cold storage. But if you are recovering the private key, then you would be using just the hot storage and the cold storage, because on every single process, the auth storage is basically discarded. Like you don't store the auth storage on device. Like every time that you just stop doing something within the app, then the auth storage is removed. And so you'll have to like regenerate it and recover it again within those 2, that then stores the new generated storage within the auth. Right. So here, I'm just trying to outline as well like kind of like how OpenSigner stands across like other solutions in the market. I think like for me and like for our team, the most interesting aspect of it all, if you're thinking on the long term, is like how much locked in you are within a wallet system that you might be using. And so like I want to stress very much like the whole vendor login and like being MIT that anyone can use. This is actually very important because like the more like as the space moves more compliance and like more enterprisey, you get like some requirements from people saying, hey, I actually want to understand the system. I actually want to host this part of like some part of the system within our compliance kind of like buckets or compliance sandbox. And so these sort of implementations do a good job at allowing that. Versus the other part where you probably have to go, it's like, let me show you like my, SOC 2 certificates. Let me show you like all these different attestations that I can do, et cetera, without actually accessing the system in itself. And then, the last part that I want to mention here is on the signing cost. sorry, the signing speed. One of the, because you are actually self-hosting this system, you actually can decide where the replicas of the cold storage live. And so in an event of, if you're targeting a specific geography of users, then it wouldn't really matter because you have the cold storage within like a specific geography, and then it's completely fine, it's completely fast. But as you like grow within like different geographies, you can actually distribute this cold storage within like different geographies, and actually beats most of solutions out of the park, because for the most part, all these all these services like other wallet infrastructure solutions would say like, yeah, if you want to have like this specific SLA, or if you want to have like this specific performance, and you have to go into like an enterprise deal, and like you have to pay as much, et cetera, et cetera. With this system, like you literally just have like the cold storage co-located in whatever server geography that you need based on your on your user behavior, and it's kind of like almost free. Like it costs nothing to store like a cold storage. It's like a very simple database, as a matter of fact. And so that's also like a very interesting value proposition of OpenSigner. So yeah, to recap, pretty much like the way that we design OpenSigner, again, is like to be completely non-custodial. So you can offer very smooth UX with familiar methods, etc., at the expense of not having to deal with like all the private key and like all these, all the issues that happen to go with that. It's designed to be zero login. So, I mean, I didn't put like the code block, but because I usually find it just loses in this type of situations. But like you can literally, it's just like a Docker file. Then you can run like the Docker file within an instance and just start using it. It's MIT, and then it goes extremely fast if you collocate it in whatever geography that your users are. Yeah, that's it. If you enjoyed it, please fork it, use it, give it star. And yeah, thanks a lot for your time.
We can take some questions right now. We have a couple of minutes.
Thank you. One question: if you fear losing your passkey device, which I do, can you have two of them, like one or the other for recovery?
Yeah, so usually passkeys are linked. It's our domain-bound encryption methods. And so for the most part, if that, like, I'm assuming you have, let's say you have like an iPhone, and that's where like you store the passkeys or something similar. Like usually these iPhones, they have like their backup within the iCloud. And so if you buy another iPhone and like log in, or like if you go through a computer and you log in through like your Apple iCloud account, you're good to go.
Okay, well, but if I have a FIDO key, I lose it, or if it's on Windows Hello, I reset the NGC, so that's
that would be
lost. So what's your solution?
Yeah, that would be problematic. In that case, what we usually, like the end state of this sort of solutions works towards either social recovery or zk-mail. And so the idea here is like once you have this EOA, then you probably go to, like you want to go towards having a smart contract wallet or something similar. And then it's like within this smart contract wallet that you would just regenerate another signer, and then you're good to go. Like the best developer practice here is like you have this implementation that gets you like 95% there. And that for edge cases where you want to start, like when you actually have a lot of money and things like that, then you're probably already using like a multisig. And if you don't, like you should. And then in that multisig, you just like regenerate the signer that you lost. And that should be good.
We can take one last question.
Hi. So you mentioned PRF and biometrics, and that you're excited about it, and I share that sentiment. It's just I would like to echo what the other gentleman said. Like there is actually a point of friction at the moment, right? That the biometrics and PRF in general is super tied to the ecosystem. So like if I have a MacBook and I have an Android phone, like I can't really seamlessly, and it's not about a recovery, it's just about like you co-using them at the same time, right? Like how do you eliminate that point of friction going forward so that I don't have to regenerate the signer, but I can like seamlessly use both at the same time?
Yeah. So my experience with this, there's an improved version of passkeys that are like a WebAuthn improved version that they're discussing within the community now. That what they're actually doing is like tackling this specific issue that they want to be able to migrate the domain bound passkey to whatever other domain bound that you want to use. So in theory, like this is something known by the community already, and so they are working towards making it more portable, if that makes sense. But again, like it's not there, but I feel like for the most part, whenever you start talking with the actual users, like any kind of like security option or like security setup that you have brings some good solution, but it also comes with like some, like for instance, passwords are great, but like people forget PIN codes, like people forget long passwords and stuff like that. So everything's kind of like on the step towards like going to that direction. And so in the case of WebAuthn, it's kind of like the whole, I don't remember the name of like the association that like is FID or something, I don't remember, but they're actually working towards like this portable characteristic or like feature of passkey. Yeah.
So thank you for presentation and thanks for coming.
Yeah, thanks guys.